Right, we have a few special situations. We always have a few special situations, don't we? If we look at these two, they're already in slope-intercept form for us, so we can graph them. Y-intercept of 1, so up 1. Slope of 2, so up 2 and right 1, or down 2 and left 1. Graph that line. There we go. The next one, we have a y-intercept of -3. Down here. And again, a slope of 2. What do we know when our slope is equal? What do we know about those two lines? Go ahead and graph this. When we have equal slopes, we have parallel lines. We should see our parallel lines right here. When you have parallel lines, when are they going to intersect? They're not. So if they don't intersect, our answer is going to be no solution. There is no point that we can plug into both equations and have it work for both of them. So that's a no solution problem. If we look at this one, these need to be moved into slope-intercept form. First one, we're going to subtract 2x. Y equals -2x plus 4. I'm going to graph y-intercept of 4. Slope of -2, so up and left or down and right. Okay, and the next one we also want to solve for y. Subtract our 4x. 2x equals -4x plus 8. Divide by 2. That should be a y there. Y equals -2x plus 4. That's exactly the same line we just graphed. So this is going to be, it's going to lay right here on top of that line. Every single point that works in this equation also works in this one. So we're going to say infinitely many solutions. There's also a way to do this where we list specifically what they're going to be, but we'll work on that later. But for now, we're just going to say we have infinitely many solutions. Right now, the only graphs that you know how to make are linear graphs. But reading nonlinear graphs is an important skill. This is something I would already give you the graph, and I would want to know what is the solution for both of these, for this system. So we're going to look for where these lines intersect. We have our linear equation and this one here. Sorry. We have this one right here, which is a parabola. And we want to know where those two intersect. Well, they intersect right about here and right about here. We don't know what the equations are, so we're going to estimate about where those 2 points are. The bottom left one looks like it's at about -2, 0, and the one up on the right looks like it's over 3 and up almost 5, so that's going to be the 0.3, 5. On these, you're just estimating to get as close as you can. All right, here's your two systems of equations to try. Go ahead and graph those and give the solution.